Hi guys, Audrey here. So today we're going to do a partial fractions problem that starts with a substitution. So in this problem, the first thing we need to do is figure out which substitution is a good substitution. So we've talked about how when we have a radical or a square root in this case, sometimes letting u be the thing under the square root or even the whole square root is a good idea. In this case, because that square root is in the denominator with other stuff especially, it's going to be a good idea to rationalize. In other words, to let u equal to the whole square root. So I'm going to let u equal to root 2x plus 4. Now remember, when we let u equal to square root, the first thing we do is square both sides to get rid of that square root. So u squared is equal to 2x plus 4. Now, at this point, we can take the derivative of both sides. And let's remember, we're taking the derivative of both sides. So I have 2u du equals to 2 dx. Okay, awesome. So what that means is that 2 dx right there is getting replaced with 2u du. All right, so let's go and replace everything. What I notice is that there's this x right here. And I'm going to need to replace this x right here. So what that means is I need to solve for x. So this is also a reverse substitution. We are going to solve for x. So 2x is equal to u squared minus 4. X is equal to 1/2 of u squared minus 4. Notice how I wrote that 1/2 out front. That's going to make it easier to deal with the constants and to not mess up what goes in the numerator and the denominator later. So let's replace everything in the integral. First, in the numerator, I have a 2u now, replacing that with a du there. My x is 1/2 times u squared minus 4. And my root 2x plus 4 is u. Now, if you'll notice, those u's cancel out. And what I end up with is a 4 times the integral of 1 over u squared minus 4 du. So remember, division by a fraction, so in this case, division by 1/2 is the same thing as multiplication by the reciprocal. So division by 1/2 is the same thing as multiplication by 2. All right, so now we have a polynomial over a polynomial. It's not a known form, so we can't just like write down the answer. Substitution, I would need a u on top for the substitution to work. I would say w is equal to u squared minus 4. dw is equal to 2u du. I need that 2u. I don't have it, so that substitution does not work. So we're going to move into partial fractions. Rational function over rational function. Rational function, what am I saying? Or polynomial over polynomial. So the first step of partial fractions, remember, is to divide if necessary. No division necessary. The degree of the numerator is smaller than the degree of the denominator. Our next step is to factor the denominator, u squared minus 4. Now this is a difference of squares, so we can easily see that it will be u minus 2 times u plus 2. All right, good. So this brings us to our third step, which is to create that partial fractions decomposition. Now notice we have two linear functions. They're both unique, they're both distinct, so this is actually a case 1 partial fractions problem. So for our step 3, that means they each get one fraction to themselves. So in other words, 1 over u squared minus 4 is equal to a over u minus 2 plus b over u plus 2. Now for our fourth step, when we solve for those numerators, we're multiplying both sides of this equation by u squared minus 4, which gives us 1 is equal to a times u plus 2 plus b times u minus 2. So here we have two zeros of the denominator. Our zeros are u is equal to -2 and u is equal to +2. So we'll plug those in over here. U is equal to -2, which gives us 1 is equal to 0 plus b times -4, which means b is equal to -1/4. Okay, so then we're going to plug in u equals 2. Which gives us 1 is equal to a times 4 plus 0, and we get that a is equal to a fourth. So now we've solved for our numerators. We want to rewrite the integral in terms of the partial fractions decomposition. So let's go to the next whiteboard, and we can say that this is therefore equal to 4 times 1 over 4 over u minus 2 minus 1 over 4 over u plus 2 du. Let's go back and check that we did that right. So our a was 1/4, so that's 1/4 over u minus 2, and our b was negative 1/4, which is why we have that minus there. Awesome. Okay, so now notice I can actually redistribute that 4 back through to get that this is 1 over u minus 2 minus 1 over u plus 2. Again, an important thing to notice here is that those 1/4 that I got, those fractional constants that I got, I didn't put the 4 in the denominator. I left it as 1/4 in the numerator both times. That helps me to more easily see that that 4 could be distributed. All right, now both of these are known forms, so we're pretty much done. This is ln of u minus 2 minus ln of u plus 2 plus a constant. Now remember, u was equal to root 2x plus 4. So this gives me ln of root 2x plus 4 minus 2 minus ln of root 2x plus 4 plus 2 plus a constant, and that's my final answer. That's it. That said, sometimes you might see this answer written a little bit differently, and that's going to be because of our log rules. So we can remember that ln of a over b is equal to ln of a minus ln of b. Oops, that got kind of blurry. So minus ln of b. In other words, if we wanted to, we could use this rule to rewrite this thing like this. Ln of the top 2x plus 4 minus 2 over the bottom will be 2x plus 4 root 2x plus 4 plus 2 plus a constant, and these represent the same thing. All right, that's all. Bye, guys.